Hey everybody, welcome to Data Umbrella's webinar. I'm going to do a brief introduction and then Juan Louis will, I don't know if, maybe you'll let me know if your name is Juan Louis or Juan only. We'll do his presentation and then we'll open it up for Q&A. We'll try to answer Q&A along the way. If you have any questions, post it in the chat or the Q&A and we'll answer them as we can. And this is being recorded. A little bit about Data Umbrella. We're a community for underrepresented persons in data science, and we are a nonprofit organization. This is our team that makes all of these webinars happen behind the scenes. We have a code of conduct, and we thank you for helping to make this a welcoming professional community that people want to keep returning to. There are various ways to support Data Umbrella. The first and foremost is to follow our code of conduct. We'd love it and appreciate it if you could share our events with other people in your network. And we have a bunch of open source projects that you can contribute to if you're interested, such as timestamps for this video. We do timestamps and it helps viewers find the video. We have a website on GitHub. We also have a Sprint website for PyMC. As well, our blog is open source and we had a data events board as well. Other ways that you can support Data Umbrella is to donate to our nonprofit. We are an open collective as Data Umbrella. And if you work for a company that uses Benevity, whatever donation you make, Benevity matches it, or your company matches it dollar for dollar. You can subscribe to our YouTube channel. In a minute, I'm going to share the link in the chat. We have over 100 videos, all data science, open source, and career development. One of our playlists is career advice, and this is a list of our other playlists, such as data science, data visualization, contributing to scikit-learn, PyMC, NumPy. We also have a monthly newsletter, which I'm going to share. We only send the newsletter out once a month, and we don't send you any other emails, so no need to worry about spam, and we don't sell your email address. This is a QR code to get our quick links. We use Big Marker here, and we have live captioning. So at the very top, it says CC for closed captioning. So if you'd like a live transcript, feel free to turn that on. We also have an online suggestion box, and I will share a link to that as well. If you have suggestions for future event topics, if you have some feedback on this event, if you experience any technical issues, and any other feedback. Our next upcoming event is on October 3rd, which is Introduction to OpenRefine for Data Cleaning and Reconciliation. Today's talk is Into the Rabbit Hole, Debugging in Python. Our speaker, Juan Louis, there we go, it's Juan Louis, works as a developer advocate at Quantum Black AI by McKinsey with a focus on Kedro and open source data science framework. He has a decade of experience as developer advocate, software engineer, and Python trainer in several industries. PSF fellow since 2017. He has made significant contributions to the PyData stack, published several open source packages, and organized the first 7 PyCons in Spain. Wow. Currently, he is the lead organizer of the PyData Madrid monthly meetups, and you can find him on GitHub at AstroJuanLu and LinkedIn at Juan Louis Canor. And with that, I'm going to go on mute and I'm going to turn over the camera and the speakerphone and the screen share to Juan Louis.
Excellent. Thank you very much, Roshama. Hello, folks. Let me share my screen. There we go. Please confirm that you can see my slides. I'm going to have a quick look at the chat just to make sure.
Yes, we can see the slides.
Excellent. Thank you. Into the rabbit hole, debugging in Python. So let's get started already. There's a number of topics that I want to cover first. Basically, an introduction of why debugging is important and talking a little bit about where do bugs usually come from, the different types of debugging that I conceived, some useful techniques that I usually use that belong to the problem-solving space that you can apply for debugging as well. Some recommendations to be careful to your future self. We're going to see why. And then I'm going to jump to do a couple of very quick, simple demos on some tips and tricks to debug on Jupyter and VSCode. So first of all, can you please raise your hand or react with the hands emoji if you had to debug some code for much longer than expected? I'm going to react myself because this has been my whole life for many, many years already. And I have good news and bad news. The good news is that one gets better with practice. The bad news is that it takes a lot of practice to get better, but you have to start somewhere. And so I want to start conceptualizing some of the things that might help you in becoming a better debugger, and as a result, a better programmer. So I was already introduced, but just to restate, my name is Juan Luis. I'm originally an aerospace engineer that then became a coder, then a developer advocate, and at this point, I'm a product manager at McKinsey for a very interesting open source project called Kedro, which is a Python framework for data science. We're going to see it in action at the end of this presentation. And in general, I'm passionate about tech communities and doing things in community in general, specifically the solidarity economy, cooperatives, and so on. At the moment, I'm organizing the monthly PyData Madrid meetups, and I've been very involved in the Python community in Spain in general, and I've contributed to several packages in the PyData and SciPy ecosystem. Sometimes bigger things, sometimes just typos or small fixes, but a contribution is a contribution. So I would be super happy to connect with you folks on LinkedIn. So first of all, why debugging is important in the first place? Well, because you will spend a lot of your coding time doing it. I was looking for some quotes to support this intuition that I had, and it turns out that according to some sources, developers spend 75% of their time debugging. There's this napkin math calculation that says that this amounts to 1,500 hours a year, which, if you think about it, is a lot. And then I sourced some quotes directly from the Software Engineering Stack Exchange, and there was a person that stated that they spent 80% of their time debugging. And I even found a quote that I didn't reproduce here of someone that was really upset and feeling that he was spending 90% of their time debugging their coworkers' code. So it happens to the best. But enough with anecdotes and personal quotes, right? Because we're really bad at doing a self-assessment on how much time do we really spend debugging. So I looked at some scientific articles and research on how debugging works and what can we learn from programmers doing debugging. And it turns out that the amount of time that people spend debugging is really it's really wide, so it has lots of variance. Sometimes it's 30%, sometimes it's 90%. But whatever way you measure it, it's a significant chunk of our time. And then I found this other article which contains this very interesting quote in the introduction. It says, debugging was frequent, even in programming work, occurring once every 8 minutes. So this was a setting in which they assigned some tasks to participants. And apparently they had to debug or solve some problem with the code once every 8 minutes, which, if you think about it, is a lot. And then debugging episodes vary greatly in time. And some of them were just a few minutes long, and a few more were more than 100 minutes. So sometimes the participants were introducing bugs that were so dense that they had to spend more than an hour debugging the results. So naturally, most of this debugging time is spent in long debugging episodes. So long story short, you will spend lots of time debugging. So to become a good programmer, you will have to become a good debugger as well. Now, a couple of words about sources of bugs. I introduced lots of memes in this presentation because otherwise programming can be a deadly activity, right? So sometimes we don't understand why the code works, and sometimes the code works and we still don't understand why, right? So if we think about it, bugs, which can be either the code crashing or the code completing but not giving the expected results, can be caused by a number of different reasons. So it's important to at least attempt to sort them from most likely to least likely. So I came up with this list of reasons. This is not something official or super structured. It's just a number of things that I considered. So for example, I would say that the most likely reason for a bug to occur is a defect in our own code, followed by things like outdated or incompatible dependencies, something about our environment, for example, the environment variables that we have, or the system libraries that we have in our operating system. Requirements miscommunication, which is someone who told us what the code needed to do did not explain that correctly, and that is naturally a source of bugs as well. Then it can also happen that there's a defect in some of our dependencies. We're using hundreds and thousands of them, so it would be really weird that all of them were working perfectly. Could be a defect in the operating system as well. This is very, very rare, but for people doing some sorts of low-level work, definitely it could happen. And it could be cosmic rays causing bit flips. Yes, and I promise this happens. And in fact, I was working in the satellite industry for some time. And I can assure you that we got a bug because some 0 had to be a 1 or vice versa. And the only likely explanation was some gamma rays from space. Obviously, there are so many other things that I didn't consider here, but this is just to give you an idea that there are so many things that we have to consider. And when applying problem-solving strategies to finding bugs, we have to take all of these into account and be somehow rational and reasonable about which ones should we look at first. In most cases, though, in my opinion, we will be dealing with defects in our own code. There's an acronym for this, which is problem exists between chair and keyboard. And this might look silly, but it happens very often for beginner programmers that they think that, pandas is broken or Python is broken, things like that. But the most likely explanation is that they misunderstood the documentation, or they're doing something funny with the syntax and things like that. So we have to be humble and always look at our own code first. Now, types of debugging. Again, this is not an official classification, but it's one that I came up with that I find really useful to kind of understand the kind of ways we can debug a program. And in my opinion, you can categorize them into more or less 2 of them. So the first one is tracing, which is watching a program, watching the program logs and analyze how's the flow of execution, and hopefully use that information to detect problems. This is also known as print debugging. And there's lots of scorn around using print statements for debugging or print functions. But the truth is that print is just fine for debugging, and it's often much better than nothing. So you don't have to feel ashamed for using it. Although there are some tools that we have both in the Python standard library and also as part of some third-party packages that can help us produce much more interesting and useful traces, logs, and so on. So I'm mentioning here logging from the standard library that some of you might know. And I want you to take a look at one third-party library that I use a lot in my personal projects, which is called Structlog, which tries to, on one hand, amend some of the weird things in the standard library logging API, and on the other hand, provide an experience that is as seamless as possible. So here's an example of how it looks like. So you see that I'm importing Structlog, and then I'm getting the logger, and I'm calling the info, warning, and error functions here. And the interesting thing is that this is happening on a Jupyter Notebook, right? So I do have rich output here with colors and so on. But if I were on a terminal environment or things like that, I can also get this rich output and have my logs easier to read, basically. And one more interesting thing is that you can pass any object to the logger functions. So for example, you see at the end of the logger.error that I'm passing this arbitrary property called logger object, and just passing around my logger. And Structlog represents that in a structured fashion so that I can see what are the properties of this logger and so on. So I find this extremely handy and much easier than remembering how to configure the logs in the standard library and so on. And then the other family of techniques could be interactive debugging. So basically having some tooling that is capable of advancing the program execution step by step and allow us to query the state of the program. And what I mean by this is analyzing what's the values of the variables at each intermediate step. Maybe we can call a function in the middle of the execution and see what the result is like, and so on and so forth. So if the code has no logs, then basically there's no alternative, right? If you want to understand why a program is misbehaving, you need some sort of information, and sometimes interactive debugging is your only choice. But if your program is running in a remote location, for example, it's running in some server, or it's running on a continuous integration system, so it's meant to run for a few minutes and then stop and produce some logs and results and so on. Or if this program is executing while you're asleep, because this is some process that takes place once a day or once a week, and you cannot really control when this software is triggering, then doing this interactive debugging can be extremely hard or even impossible. Some continuous integration systems, such as Circle CI, allow you to open an SSH session to the CI job so that you can perform some interactive exploration of the environment and so on. And as far as I know, GitHub Actions is also capable of doing that, but it requires a little bit of process to get that working. So provided that you're not in any of these situations and that you have a debugger of any sort, this can be really powerful. So Python ships a very primitive debugger. We're going to see that too in the demo part. And your IDE, if it's Jupyter with some extensions, as we're going to explain later, or VSCode or PyCharm or any other editor of your choice, has a much better one at your disposal. So, for example, this is a screenshot of how the debugger in Jupyter looks like. It's not important now to have a look at all the elements, but just for you to know that you have the coding area in the center, and then usually on the right, there's a debugging toolbar where you can see some expressions, the values of the variables, the number of breakpoints that we have, and so on. And then this is how a similar thing looks in VSCode. So again, you have the code in the center, and then on the left, you have some extra tools that allow you to step into the functions or step over the functions and display what's the value of the variables and so on. But the important thing here is that debugging is problem solving. So if there's only one thing that you're going to extract from this talk, is this part here. So problem solving is in general applying some structured technique to try to solve some problem. And, for complex problem solving, this requires a lot of nuance and so on. But we're lucky that computers are mostly deterministic. This is a joke because we can, by all means, consider computers that are deterministic. And so this means that some things that look like random or the act of some evil god that wants to play a joke on us is actually something that is caused by a very specific set of things and has a very specific root cause. In most of the cases, this root cause would be more or less straightforward to fix. In some others, there might be some external factors that make this very difficult, right? For example, if the network is flaky, or if there's some system that is very unstable and so on, determining what is causing some behavior will be hard, but in most of the cases, it shouldn't be that way. So basically, lots of problem-solving techniques exist, and we can use them while coding. So here I'm listing just a few of them. So for example, one very popular technique is divide and conquer. This is actually a family of techniques. And the definition from Wikipedia reads as follows. So a divide and conquer algorithm recursively breaks down a problem into two or more sub-problems of the same or related type until these become simple enough to be solved directly. And there are many examples of this. For example, if you have some code that is really long and you're not sure where exactly is it failing, one idea can be to split that code into smaller functions and then analyze the behavior of each of those functions in isolation. And another very famous way of applying divide and conquer is doing git bisection. So for those of you that don't know, git bisect is a command that takes a commit where we know the code is broken and a commit where we know the code was working well. And naturally, we can assume that something broke in the middle of it. If it was working well at the beginning and now it's broken, it's clear that at some point something changed. If we assume that the problem lies only in the code, which is already an assumption, right? Then there is a process that is actually quite fast in which we can analyze a subset of the commits. There's an algorithm that allows us to not having to analyze all the commits. And then git bisect will point us to what exactly is the commit that broke the code. So again, if you're writing small commits that have a specific meaning and so on, you're going to make it much easier in the future to apply this sort of technique. And another one is hypothesis testing, which is nothing more than applying the good old scientific methods to coding as well. So again, the definition from Wikipedia, assuming a possible explanation to the problem and trying to prove, or in some contexts, disprove the assumption. So for example, let's say that I have some code that is broken, and then I want to formulate an hypothesis. And it's that the brokenness is caused by the pandas version. Maybe this is in the process of some debugging, and I have tried a number of other things, and I'm not sure exactly what is causing the issue, but I formulate this hypothesis. Well, now the way to prove or disprove that hypothesis is by testing exactly the same code and they're exactly the same conditions under two different versions of pandas, and then see what comes out of that. So there's basically two possible results. If the bug still appears in both pandas versions, then we're not sure, right? We could keep trying pandas versions over and over again, but it's not practical to try all the pandas versions. So we either continue for a while or we think of another possible cause. On the other hand, the moment that we find one pandas version that produces a different behavior, then there is very strong evidence that that could be the root cause. What's the trick here? Well, the problem is that replicating the exact same conditions is really hard because maybe you think they are the same conditions, but accidentally you're missing some environment variables in your second environment, right? Or maybe the time of the day is playing a role and things like that. So isolating the experiments so that they are exactly the same and we're only changing one factor is really hard, not only in computing, but in general. This is a known problem in statistics, for example, when we talk about confounding factors, or in medicine, when we talk about double-blind experiments, and so on. So this is a really good technique, but you have to come up with good hypotheses to test, and you have to be very careful at splitting the experiment so that the right conditions are met. Another possible technique could be reduction. So again, copy-pasting, transforming the problem into another problem for which solutions exist. And there's numerous examples of this again. So for example, when we're asking in some forum or Telegram chat or support channel of any sort about a problem that we have, and someone asks us to produce a minimal reproducible example or a short, self-contained, correct example, that's exactly what they're asking us. So maybe the conditions under which our bug appears are very complex and difficult to reproduce for someone else. But if we can narrow down that problem so that we can create an equivalent problem that showcases the same behavior, but in a way that is much easier and simpler to understand and reproduce, then this is already a very good path towards finding the solution. Or for example, if we're doing some processing with some data frames or something like that, some tabular data, and we know that our code is failing for some reason, but our table is really big and it has lots of columns, and it's really difficult to understand what exactly was breaking. So again, trying the same code, but with a reduced version of the table, maybe only 5 rows, maybe only with the columns that are affecting the result, is again a form of reducing the problem. And if you think about it, we're also applying divide and conquer here, because we have to split our problem so that we produce a simpler version of the problem, but it still has to exhibit the broken behavior. And finally, one really underrated technique that I recommend to everyone, which is reading carefully. I used to tell this to my students when I was teaching Python for data science. And to this day, it's a super valuable skill. And I will give you a very specific example. This is a bug that someone reported in Kedro a mere week ago or a few days ago. And it was something around not being able to configure Kedro to run on PyCharm. And he was getting a super weird error here. So I'm going to open this in a new tab so that we can see a little bit better. And, you know, the thing is that many people, when confronted with a traceback, they give up immediately because a traceback is so overwhelming, right? It's lots of text, lots of lines. It's difficult to read, difficult to understand what's going on. Sometimes the error message is not really related to anything that we're doing. So people used to get really lost when they see these kind of things. And it's a skill, you know, to understand how the traceback works and what parts of the traceback we can paste on our search engine of choice or Stack Overflow and get an informative solution, because we cannot just paste this on a search engine and expect to get a good solution here. Maybe generative AI systems are getting better at understanding Python tracebacks, but I don't think general artificial intelligence is still among us. So I'm going to give you a couple of seconds for you to tell me what is wrong with this traceback. You can drop your comment in the chat. I pinged something a little bit already, so I'm going to give you 10 more seconds. Okay, and regardless, I don't have any t-shirts or stickers to give away, so there's no prize. But if you look really closely at the traceback, you will see that at some point there's an import logging here, right, in the middle of the code. And we know that logging is a module from the standard library. So if everything is correct, the next thing that should happen after one imports logging is that we should get dropped into the Python library code. But instead, what's happening in this case is that we're getting dropped to another part of the code. So apparently there's a logging module inside Kedro. And because of how this user was running the code, it turns out that import logging was not getting the standard library logging, but the Kedro logging. And of course, you can imagine the sorts of problems that can arise if you replace something from the standard library with your own code, right? Luckily, the solution for this problem was really easy. They had some path issues and they were running Kedro in a very unusual way, and just changing one line of their settings was enough to solve the problem. And I didn't even have to get into a debugging session with this user or ask them a lot of information. I saw the traceback and I immediately noticed that something was off. So I'm about to wrap up with this introduction, and I want to dedicate some words to your future self, sometimes your worst enemy. I also love this meme a lot because sometimes you're looking at some code and thinking, who the hell is writing this? And then when you perform a git blame operation or you look into the GitHub history and so on, then you find out that it was your past self that was writing this code. And this happens really, really often. So there's this quote that I found: always code as if the guy who ends up maintaining your code will be a violent psychopath who knows where you live. And I think it's really, it's a little bit violent, but it's really useful to think about how we can help our future selves to perform debugging easier, basically. So the most important lessons is that you will need to debug your code sooner or later. So you better plan accordingly. And here are some quick tips that I came up with. So first of all, invest time in mastering your tools. Part of the demo now is going to be about that. There's lots of religious words about editors and tools and so on. And honestly, you should not let anyone mock you, whether you're using Vim or Notepad or Atom, VSCode, Jupyter, PyCharm, whatever other editor of your choice. What should be important to you is that if your editor is not helping you debug your code, then you either have to improve it, extend it, or find something else, because it's going to be the most important tool for you when finding problems in some code. A very silly one: use meaningful variable names. We're sometimes in a rush and want to write that A equals 1 and B equals 2 and X, Y, Z, and so on. But these variable names are really cryptic and are going to make our debugging life much more difficult. So try to strike a balance between variable names that are super long and variable names that are just one letter or too short. Then write good code comments, and good code comments are those that explain why are you doing such a thing, and not just describing what the code is doing. Because when you see the code with more or less work, you can understand what it's doing. But why that code is there is something that is completely lost unless there's a human being explaining there why the code is there. And that might be because it's an unusual piece of code that maybe looks like it shouldn't be there. So you have to explain why it's there. Or maybe it's preventing some bug that you became aware of, and then it's good that you explain why that code is there, and so on. So don't just explain the code, explain why you're putting that code there. Add logs. Again, the more the merrier. Probably there's a point in which there are too many logs, but I contend that it's better to have too many logs than no logs at all. So again, try to strike some balance and produce some information that is useful for your future self. And finally, if you structure your code in functions and you place side effects outside of those functions as long as possible, your code is going to be much more easy to debug as well. I really enjoy this talk by Brandon Rhodes in 2015 about hoisting your I/O. And it's basically about removing side effects from your functions and writing functions in a way that they can take generic objects and not necessarily perform any I/O operations inside. So that is it for now for the slides part. So I'm going to go to the Q&A tab and see if there are any questions from the audience. Reshama is saying, wondering why this is the first time that I have heard of Structlog. I highly recommend you to check it out. If you see the website here, you will see that it's really well explained. It has a cute logo as well. Let's give it some seconds to load. Well, I will give it some more seconds. But regardless, it's a really useful library. It's really well integrated with Reach. It's a pleasure to use, and it's a very cheap abstraction. It virtually has no dependencies, and it's really lightweight. Yeah, this one here. Reshama asks, what is Reach? Really good question. I kind of mentioned it, but I didn't explain it. So Reach is a Python library that allows users to create terminal interfaces and text interfaces that have lots of color, formatting, and so on in a really nice way. So again, if you check out the GitHub repository and the documentation, you will see that it has lots of really interesting features. So it allows you to control the colors of the terminal in a really fine-grained way, even the formatting of the text. It allows you to produce Python tracebacks that are formatted in a way that are easier to read, and so on. So again, really highly recommended library and really good documentation as well.
So, okay, so the first question, sorry, I should have asked you this in the beginning, but your name is Juan Louis, is that correct?
Yes, correct.
Okay, all right, that's good to know. The second question, I just have a quick question, which is, some of the slides that you showed with the screenshots were so small that I wasn't able to see. And I was just wondering if later, you can do it later, but if, like, I think that one you expanded
This
on,
one?
but yeah, that one you expanded on, right? Yeah, that one, actually, if that one were bigger, that would be helpful. And then I think a few in the beginning, but you can do it later as well.
Sounds good. Yeah, we can go over that in a moment. But yeah, like to repeat this one here, that was a little bit small. As you can see in the circle, the code is doing import logging. But then instead of going to the Python standard library logging, it's going to this side packages kdraw login.py. So here we immediately see that something is off. Then about the other slides, oh yeah, like the debugging interfaces and so on.
Yes, that one, because I'm even looking on my large screen and I can't see that one. Yeah.
Yeah, thank you for that. So we're going to see an example of this in a moment, but this is how the JupyterLab debugging interface looks like. So you see the code in the center, but then on the right, you have a variable explorer. So you see all the variables that exist in the environment at the moment with their values. Then you see the breakpoints. So the lines of code where you commanded the debugger to stop. And you see a representation of the source code as well. So that is one. And then the other one is this one. So this is how the VSCode debugging interface looks like. And again, you see the code in the center, some extra information about the traceback highlighted there. And on the left, you see on one hand the variable explorer here. So you see again all the variables that exist. Here you see some extra variables that you're watching for whatever reason. And here you have something called the call stack. So basically the tower of functions that you're calling and at what level of the tower you're in at the current moment. So going back to the end here, before going to the demo. Okay, Juliana is asking, I think an important skill is finding a Stack Overflow post that works for solving your bug. But that seems so abstract. I don't even know if there can be an example. Do you have any tips? It's a really good question, Juliana. Indeed, finding a good Stack Overflow post that tells you exactly what went wrong is, and I agree with Juliana here, a skill in itself. So one thing that I can say, for example, if we zoom in back in this traceback here, this is a lot of text, as we were mentioning. So you have to understand what parts of this text are going to be more relevant for the problem that you're trying to find, and what parts you should completely discard. So, for example, when talking about Python traceback, usually the last line is the one that you want to focus on, because higher up in the stack is your user code, right? And at the bottom of the stack trace is the code that failed. This is the contrary as happens in Java, for example, where the code that fails is on top and then the user code is at the bottom. So one important thing is to locate that last line. And then you have to be good at determining what parts of that line are sort of generic and what parts are because of your code. For example, in this case, it's more or less clear because it's failing to initialize the login module, and it complains about handler class that cannot be imported and so on. There's nothing here that you wrote, not a variable that you named or anything like that. So you can probably like copy paste this error and embed it, and we will find something. It's not guaranteed, but it's a possible explanation. However, if the traceback has something like variable A not defined, then the name A is not important because it could be A, B, or anything else, right? So when looking for a solution for that problem, you have to remove the information that is too generic or that depends on the code that you're writing and so on. So long story short, first, I will focus on the last line of the traceback. And second, I will try to remove the information that does confuse the search engine rather than specify what the information is. Reshama asks, when sharing a report on GitHub, we should use backticks instead of a screenshot? Absolutely, yes. In fact, if I go to the actual report of this issue, and I can share the link with you in the chat. Oops, that was a Q&A, sorry. There we go. You see that this person did the right thing. So we provide our users with a template to help them understand how they can report bugs and so on. And they did send some text that I can basically select, copy, paste, and so on. If you attach a screenshot to your issue report. That's really annoying for maintainers because they have two choices. They can ignore you, but that is going to be bad for the reputation and it's going to not be helpful at all for you. Or they can do the extra mile and try to help you, but they have to type character by character that error message that you're sharing with them. So when trying to make someone else help you, always make sure that you're sharing some text and in general, make the life of the person that is helping you as easy as possible. Okay, I see in the chat that Rashama was sharing some resources and there's no more Q&A. So without further ado, let me review a couple of tips and tricks for the demo part. So I'm going to maximize my screen again. So first of all, let's talk about, okay. So that was it. So closing remarks, you will spend most of your coding time debugging. So plan accordingly and sharpen your tools and make a deliberate effort to get better at it. So you have to master the editor that you're using so it's as helpful to you as possible. And you have to learn several problem-solving techniques so that you have different strategies at your disposal and you don't get stuck, basically. Make your life easier also for your future self. So write useful comments, add informative logging, use good variable names, and so on. And happy coding. So thank you very much. Mm-hmm. Okay, so any last questions?
Hi, thank you so much for the presentation. We'll give people a couple of minutes if they have any questions. We'll give them a couple of minutes to ask that. Thank you so much for the presentation. You're getting a lot of raised hands, so people are thanking you via emoji. I have a question, which is for newcomers to Python. What would you say is like maybe the first couple of things they should know? Because debugging is important, but it's not really something I think that's sort of taught in the very beginning.
Indeed. And I think that was why I was so happy when you proposed this topic, because I think we teach a lot, constructors and conditionals, functions, and, the syntax of Python, right? But we rarely tell people how to get out of the problems, and they will get into trouble all the time because professionals spend anywhere from 30 to 90% getting out of problems from their own code, right? So this is like the first thing to take into account is that this is not like you're not getting into problems because you're a beginner. You're getting into problems because you're a programmer. So debugging is a natural activity. So that's the first thing to bear in mind. And as a consequence, you don't have to be discouraged or lose motivation or think you're silly or you're not fit for it because you're debugging, because debugging is just programming. Then I think it's really important, beyond the things I said about trying to apply good problem-solving techniques and reading very carefully Python tracebacks and so on, I think it's really important to get familiar with the common tracebacks, and common errors that you see. Because at the beginning, when you're starting with some basic Python code, or you're learning through some platforms like Codecademy or things like that, or you're applying exercises from the Euler projects or any other sort of thing, you have to develop an intuition on, when you're just writing bad syntax, right? And you have to get out of that as quickly as possible. So the first step in your programmer joiner is to produce correct syntax most of the times. And then, when you're not making syntax mistakes anymore, you will be making logical or semantic mistakes. And some of them will be, like variables that are not defined. And this is maybe because you're defining variables in a conditional, but then you're trying to use them somewhere else and your logic is incorrect. And, there will be a series of issues that will happen at the beginning many, many times. And, asking for help, learning how to, produce these minimal reproducible examples or these short, self-contained, correct examples is going to help you a lot get help from other people, because self-learning is very tough. I know this firsthand because it took me years to learn the basics of Python, and then I could teach the basics of Python in weeks. So learning with others, it makes it much more enjoyable. So finding some sort of support network or cohort or programming buddies that are at the same level as you and help you in this journey is super important as well. And yeah, I think those would be like my first pieces of advice. Mon is asking, how does unit testing factor into debugging? Really good question. We didn't touch on unit testing here. So unit testing is the practice of creating automatic tests. And the fact that they're called unit tests is because they are very small, very short, and they cover only a specific part of the code. So they're usually a few lines long. They care of verifying a specific part of the functionality. And unit test might make debugging easier because the fact that you're testing things in isolation means that your code is already able to be tested that way, which means that in principle it should be easier to debug. So there are different practices because you might have to debug your unit tests at some point as well. But definitely getting into the habit of writing unit tests, whether you follow test-driven development or not, meaning whether you write the test and then the code, or if you're more like loosely applying that and you write the tests as soon as the code is working, that's up to you. Writing tests is going to make you debug things in a much easier way, and also it's going to help you think about the code in ways that are going to be useful as well, because you're considering every piece in isolation.
Hi. So I'll wait a couple of more minutes, but in the meantime, I just want to, again, thank you. It was a great presentation. I think what I'm going to do, and it may take a while for this to happen, is to break down your Jupyter Notebook demo into one video and the VSCode into another video. So for, people who are interested in a specific platform, they can get to it easily. So I'm going to do that, but it does take a bit of time on YouTube for that, to edit videos. So I think we'll do that. Thank you so much. And just for people who don't know, we have a monthly newsletter, and I was asking for a speaker for this topic for I think a year, and you finally wrote to us and said you've been asking for a while, I think.
Yeah, it took me a while as well to like get to it, but yeah, it was a great pleasure, and I hope we can continue collaborating in the future. And people are more than welcome to try the repository, open issues on it, tell me about other things that they're interested in, and maybe we can do a follow-up sometime soon.
Yeah, that'll be great. Thank you so much.